is okay from my side? Okay. So video audio clear hai? Not any problem?
Yes, sir.
Okay, good. So in the last class, we have learned little bit of center of mass, just definition of center of mass and how we can use to calculate the center of mass. The center of mass is very important concept. When we will go for another chapter, you will see there application of center of mass and application of moment of inertia also. So today we will just try to learn how to calculate moment of inertia. So this is the chapter, and but before that we can revise what is my center of mass. So we have our center of mass, and this center of mass is nothing but a vector, and this value is equal to, you have some r dm upon dm. So this is definition of center of mass. So you can easily compare x axis, y axis, z axis, and you can find x center of mass, or that is nothing but the coordinate. So this is your basically definition of center of mass. Now we will just try to figure it out. What will be moment of inertia? And into the calculating for calculation of moment of inertia, we have two basic theorem. The theorem is very popularly known as parallel axis theorem and perpendicular axis theorem. And we will also try to learn these two theorems. So this is another concept we have to learn. By the way, suppose I have some mass is there, and we have some axis, and let's say this axis is let's say a dash, and you have, suppose this mass is nothing but dm. Very small elemental mass you are taking, that is dm. I have deliberately make it little bit bigger so that it can just visualize much better. And this is the perpendicular distance from this particular dm. Let's say this distance is r. So what will be moment of inertia about axis a dash? So this is your axis. About that, you have to find the moment of inertia. So the moment of inertia about a dash is identified as, let's say, a dash, a dash. That is nothing but r square dm. And what is r? R is nothing but the perpendicular distance from that particular dm, that mass element dm. So ये जो perpendicular distance है, so r is nothing but perpendicular distance. So this is perpendicular distance between, obviously, between axis and elemental mass dm. So you have to just, and the whole idea is that how you will calculate the dm and how you will going to calculate this particular perpendicular distance from the axis. So let's try to calculate one particular problem, and this problem was asked into this year JAM exam also. So there is a rod, and this is axis, and this is a end of rod is O. And what we have to do, first we have to calculate center of mass of rod, and second we have to calculate moment of inertia of rod about axis. Let's say this axis is a dash, about axis A dash, and which is passing through one of the end of this particular rod. Obviously, another thing was also in the problem, but currently we are just going to focus on this particular point. And it is also given that the mass density is not constant. The mass density is basically 3m upon L cube x square. This is our mass density. So mass density is nothing but the mass per unit length. So this is linear mass density is given. Now we have to calculate what will be center of mass of rod, and then we have to also calculate what will be the moment of inertia of rod about this particular point. So let's try to calculate the basically center of mass first. So obviously here, what will be dm? The main thing is how you will calculate the dm. What is your dm? So here the mass, so what we will do, we will just take the elemental mass dm at distance x in a length dx. What is meaning of that? Meaning of that, this dm mass is in this particular length dx, a small elemental length dx. So we can easily write, hence this is nothing but the mass density, mass per unit length. Then we have dm upon dx is equal to lambda. And now you can see, first time we are going to encounter with lambda which is not constant. अभी तक जो हम ले रहे थे प्रॉब्लम, वहां पर हम क्या ले रहे थे, that lambda is constant actually, m by l. But here this lambda is function of x square. So I can write this lambda, and this lambda is nothing but 3m upon L cube x square. So what is my dm? My dm is nothing but 3m L cube x square dx. So easily we can write this dm into form of dx. So first thing is that we have to calculate, obviously the center of mass will along x-axis. So we have to calculate x center of mass, and that x center of mass is x dm by dm. And now we will take the constant outside. So what will be this value? 3m upon L cube is outside, or inside integration we have one x is there, another x square is there. So that value is equal to x cube dx between 0 to L. And here in the denominator, again we have 3m upon L cube is there, and this value is x square dx 0 to L. And what will be my center of mass? क्या आ रहा है कैलकुलेशन करने के बाद? So you have basically 3m upon, and this thing is cancel out. So this is beauty of this particular calculation. So you have L4 by 4 by L cube by 3. So that is 3 by 4L. So that means the center of mass is not at the center of rod. If it would be the constant mass, then the center of mass should be at the center of rod. So this is my 3 by 4L, and this is my center of mass. So say your center of mass will be some at this particular point. So this was one question asked into this year. Same question, they were MSQ. So, and this type of question can come into GATE exam, can come into JEST exam. So you have to just work for this type of problem. Everyone is comfortable? Now let's try to calculate what is moment of inertia. So how you will just go for moment of inertia. So you have to just again use the same concept, but definition of moment of inertia is little bit different. So again, what is moment of inertia? We have to calculate moment of inertia about the axis a dash, which is passing through edge, and that value is equal to integration something square into dm. What is this something square? ये क्या है? What is this something square?
So ये perpendicular distance.
Perpendicular distance है इस dm से. So what will be, और ये axis है. Are you getting my point? So what will be perpendicular distance?
Yes.
x, isn't it? अच्छा ये बात बताओ, अगर मेरा एक्सिस ऐसे रहता, इस पॉइंट से कितने एक्सिस जा सकते हैं? हाउ मेनी एक्सिस कैन गो फ्रॉम दिस पॉइंट? हाउ मेनी एक्सिस कैन गो फ्रॉम दिस पॉइंट? बताइए कितने एक्सिस जा सकते हैं?
Infinite.
इन्फिनाइट नंबर ऑफ एक्सिस,
Infinite.
इन्फिनाइट नंबर ऑफ एक्सिस। और सपोज करो ये एक्सिस लेने का मतलब क्या है कि रॉड को मैं कुछ ऐसे घुमा रहा हूं। आर यू गेटिंग माई पॉइंट और नॉट? अगर मैं कुछ ऐसे एक्सिस ले रहा हूं, इफ आई विल टेक एक्सिस समथिंग लाइक दिस, then is that perpendicular distance will remain same or different?
Same.
अगर मैं ऐसे एक्सिस ले रहा हूं, दैट मींस मैं रॉड को कुछ इस प्लेन में घुमा रहा हूं, तो क्या ये परपेंडिकुलर डिस्टेंस सेम रहेगा या डिफरेंट रहेगा? सेम रहेगा,
Same रहेगा sir.
सेम रहेगा, है ना? लेकिन अगर मैं एक्सिस कुछ ऐसे ले लूं, तो क्या सेम रहेगा परपेंडिकुलर डिस्टेंस?
नहीं
No.
सर,
No
So
sir.
that will be changed.
चेंज।
वो क्या हो जाएगा? चेंज हो जाएगा। Are you getting my point? So you have to always take care of this particular thing. So obviously this is very simple problem. So we have a dash, and that value is equal to, we will just put here x square, and again what is my dm? So dm will be, I can write that is lambda into dx, and this value is equal to 3m upon L cube x square into x square dx. So we have 3m upon L cube x to the power 5 upon 5, and we have to go for 0 to L, and that value is 0 to L. So what you have? You have this value as क्या रहा है? 3 by 5 m L square. So this is your moment of inertia about a dash. So you can see how we can use the basic definition, है ना? हम लोग किस तरह से basic definition को use कर सकते हैं? But actually you can solve every problem from this particular method, every problem. Don't worry. But thing is that if you have some theory, then you have to use that type of theory, and you can easily calculate the thing in a very efficient manner. So there are two basic theorem which is very useful to understand, to calculation point of view of the moment of inertia. And in general, this type of theory, this theorem is mainly for the symmetric kind of thing. Which type of symmetry I am talking about? I will just discuss this thing. So let's try to understand two basic theorem. The first theorem is parallel axis theorem, and second theorem is perpendicular axis theorem, and then we will try to solve different types of problem. ठीक है? आज की क्लास और कल की क्लास में अब हम सिर्फ प्रॉब्लम सॉल्व करेंगे, ठीक है? सो लेट्स ट्राई टू गो फॉर, है ना? कुछ पूछना है? चलिए, ओके। क्योंकि देखो मैकेनिक्स में आप सिर्फ प्रॉब्लम सॉल्व करके ही सीख सकते हो, है ना? देयर इज नॉट थ्योरी कि मैं बैठ करके उसकी थ्योरी डिस्कस करूं। है थ्योरी भी, जहां पर हम कोई मॉडल डिस्कस करते हैं, जैसे कि सन अर्थ सिस्टम की मॉडल हो गई, कैपलर्स की मॉडल हो गई, तो वहां पर बेसिक थ्योरी की जरूरत होती है। बट इन जनरल यू हैव टू सॉल्व द प्रॉब्लम्स, ओके? सो भाई मैकेनिक्स को प्रिपेयर नहीं करना होता है कि एग्जाम में उसको रिवीजन करने की कोई जरूरत नहीं। इफ यू हैव कॉन्सेप्ट, anytime you can solve it, because there is not any unnecessary formula and all other thing. Okay, chalo. So first we will go for parallel axis theorem. Parallel axis theorem. So what is this parallel axis theorem? So suppose we have any particular system, and we have center of mass, we have knowledge of coordinate of center of mass. So let's say this is my center of mass, and the axis which is passing through center of mass. So how many axes can we pass through center of mass? Infinite axis can we pass through center of mass. So this is one of the beautiful thing. So from the center of mass, you can pass infinite number of axes. So if suppose this axis is passing through center of mass, so I deliberately make little bit tilted axis, and somehow I know the moment of inertia about center of mass. अब कैसे कैलकुलेट करते हो, दैट इज डिफरेंट इशू, बट somehow we know the moment of inertia about center of mass, and the mass of the center of mass is obviously m. That is definition of center of mass, means whole mass is constituted at the center of mass, that is capital M. Now if somehow we can calculate the center moment of inertia about center of mass, and there is another axis which is actually parallel to that axis. This is very important. Another axis which is actually parallel to this axis. If I will take this axis, then these are not parallel. Are you getting my point? If somehow you have to calculate and you have one another axis, and let's say this axis is A dash, and the perpendicular distance between them is D. The perpendicular distance between them is D, then the moment of inertia about I A dash is equal to I center of mass plus M D square. Okay? So you have to always work for the parallel axis. ऐसा नहीं कि कोई भी arbitrary axis को ले लोगे. So suppose my axis is passing through center of mass like this, then what will be my parallel axis? Something like this. Are you getting my point? This axis is not parallel. Something like this. Suppose you have moment of inertia about this axis, then you have some parallel axis, something like this, and you can easily calculate the moment of inertia about this particular axis once you know the moment of inertia about center of mass. This is beautiful thing. So why you will see, अगर आप अपने school days को याद करो, NCERT book, so you have all the information about center of mass. अलग अलग सिस्टम के सेंटर ऑफ मास का मोमेंट ऑफ इनर्शिया आपको सॉल्व आप करके रखे रहते थे, और जब भी जरूरत पड़ता है आप उसको यूज करते हो. यू कैन इजिली यूज दिस काइंड ऑफ थिंग. So this is your parallel axis theorem. And next is, and yes, parallel axis theorem is used for one-dimensional, two-dimensional, three-dimensional, all kind of body. So there is not any problem. You can easily use this thing. So now let's go for perpendicular axis theorem. Perpendicular axis theorem. So what is perpendicular axis theorem? Suppose we have a some mass distribution, and this mass distribution is in a plane. Suppose this is my x-axis, this is my y-axis, and my origin is at the center of mass. This is very important. So origin is at center of mass. Okay, and this is also your center of mass, and you have some, and you know moment of inertia about x-axis. So moment of inertia about x-axis is, let's say, Ix, and similarly you know the moment of inertia about y-axis. Let's say this is Iy, and then you can easily calculate the moment of inertia Iz, that is nothing but Ix plus Iy. And this is mainly for the mass distribution which is in a plane, that is in two-dimensional system. Suppose your mass distribution in YZ plane, then how this formula will transform? Ix is equal to Iy plus Iz. So you can see on the right hand side, these two components have basically this mass distribution in this xy plane, and this is my z axis perpendicular to this particular board. So you have to figure it out. You can use these two parallel axis and perpendicular axis theorem to solve different type of problem. But the most important thing is that you have to know what is the moment of inertia about center of mass. Isn't it? Unless until you don't know the moment of inertia about some axis which is passing through center of mass and which is your convenient axis. ऐसा नहीं है कि इसमें आपको moment of inertia इस axis के about पता है तो आप यहाँ पैरेलल एक्सिस थ्योरम लगा दोगे. डिपेंड्स ऑन प्रॉब्लम कि किस तरह के प्रॉब्लम है एंड हाउ यू आर गोइंग टू यूज इट. सो अप टू दैट एवरीवन इज कंफर्टेबल.
Yes.
ओके, चलो. सो हम लोग अभी से कुछ कुछ सिस्टम को, प्रॉब्लम थ्योरी, आप जो भी चाहे इसको कह लो, आज और कल की क्लास में से हम लोग पूरा करते हैं. ठीक है. सो लेट्स ट्राई टू सॉल्व डिफरेंट टाइप्स ऑफ प्रॉब्लम. So let's try to start with the simple system. और आप देखोगे एक और बहुत ब्यूटीफुल पार्ट है कि एक सिस्टम किसी प्रिमिटिव सिस्टम से भी बना हुआ होता है. फॉर एग्जाम्पल, मैं क्या कहने की कोशिश कर रहा हूं कि सपोज आई एम टॉकिंग अबाउट रेक्टेंगल. What is the primitive system of rectangle? You can see if you have n number of rod and you are lying in the plane, then you will find the rectangle. And then you will see the moment of inertia of rectangle have some basic property of rod also. For example, you have cylinder. What is primitive system for cylinder is a disk. If I am talking about solid cylinder, so that is disk. So if you have n number of disk and sit and just lying one another, you will have shape of cylinder. So sometime this primitive shape and system will also very useful to calculate the moment of inertia. But don't worry, there is no need to unnecessarily use your brain. Just go for first principle and try to calculate each and every problem. Okay, so let's try to go for this particular problem. So I am just going to start deliberately for the simplest system, that is rod. And right now I am just taking the constant mass, and obviously this is at the center of mass, that is at center of this rod. So this is my mass is constituted there. So first we have to calculate moment of inertia about ICM, and then we have to calculate axis passing through one of the edge of this particular rod. So let's say this is A dash. So what we can do? We can easily take one moment, one axis which is passing through center of mass. There are n number of axes which can pass through center of mass, and we are taking one particular axis which is passing through center of mass. Let's say this is ICM. अगर सपोज करो इसके अबाउट निकालना रहता तो हमें मोमेंट ऑफ सेंटर ऑफ मास से एक्सिस कैसे भेजना होता? दैट इज समथिंग लाइक दिस, इजंट इट?
Yes, sir.
है ना? तो ये हमेशा आप ध्यान में रखोगे, पैरेलल एक्सिस मींस पैरेलल. You will then you can use it. Okay, so we can take what is moment of inertia about ICM. So here you have to go for the first principle only, and that value is equal to dm and something called x square. So I can take something here dx, and that value is equal to x, and hence I have chosen this one as a origin. So this will go from where to where? Minus L by 2 to plus L by 2. And what is your dm? Your dm by dx is equal to m by L, and that implies dm is equal to m by L dx. And what you have minus L by 2, x square, and I have m by L x square dx. क्या वैल्यू आ रहा है?
सर डिवाइड बाय एम
क्यों डिवाइड बाय एम क्यों करोगे? आप मोमेंट ऑफ इनर्शिया निकाल रहे हो, सेंटर ऑफ मास थोड़ी निकाल रहे हो.
यस यस
है ना? सो दैट
Yes.
वैल्यू आई थिंक यू विल गेट ml स्क्वायर बाय 12. आ रहा है क्या? चेक करो, इंटीग्रेशन आ रहा है. x क्यूब बाय 3. सो l बाय 2 को पुट करोगे तो 4 into 2 is 12 minus minus plus. So this will be ml square by 12. क्लियर है ये? Okay. Now, so you have moment of inertia about this axis, that is ml square by 12. Now we have to find the moment of inertia about this axis, just passing through this one. So you can easily use parallel to this axis, and this axis is parallel one. So I A dash is equal to I center of mass plus M d square. What is I center of mass? Is ml square by 12 plus m. And what is value of d here? बताइए.
L
What
by
is value
2.
of d?
L by
L by
2.
L by 2. So that value is nothing but L by 2 whole square. So you have ml square by 3. So you can, this is very trivial. हम लोगों ने अपने स्कूल डेज में भी इसे पढ़ा होगा. ठीक है. Now let's try to go for, and this is one of my primitive system, you can say. Let's try to go for another problem, and this is one of my favorite problem. So we have these axes. So here is my origin, and this value is equal to L. Sorry, and you can take A, and this value along Y, you can take B. So this is my x-axis, this is my y-axis. And what we have to do, we have to find the moment of inertia about the axis which is passing through one of the corner whose name is A and perpendicular to plane of this board. Means कुछ ऐसा है और ये कुछ ऐसे ऐसे हो सकता है. So we have to find the moment of inertia about the axis which is passing through corner. You have to find moment of inertia about axis which is passing through corner A and perpendicular to plane of lamina. Plane of lamina. Now, let's try to calculate this one. So, what is the idea? If you want to calculate directly about this axis, and you will take some elemental mass dm, and then you will calculate, you will unnecessarily trapped into unnecessary calculation. So, what we can do, we can make a trick. If somehow we can find the moment of inertia about the center of mass, which is at the center of this particular lamina, and which is perpendicular to this axis, then we can easily use the parallel axis theorem. है कि नहीं? Easily use कर सकते हैं. और इस axis के about निकालने के लिए, if we can find the moment of inertia about this axis and this axis, then easily we can use the parallel axis theorem. Yes?
Yes, sir.
Okay. So, and let's say this is y dash. So let's calculate I y dash. Means इस axis के about निकाल रहे हो. So you can take any mass element dm. ले लोगे dm. Now integration dm. Can you please tell me what is this square? This is most important thing. इस एक्सिस के अबाउट निकाल रहे हो and you are taking this dm. What is this square? X will be that thing, है ना? So that should be x. Sorry, dm यहां पर होगा. So this will be x, क्योंकि y axis के से जो perpendicular distance होगा, that will be in xy plane. So this is my x square. Now we can write dm. What is my dm? So you can use dm by dx into dy, and that value is equal to m upon A into B. So dm is equal to m AB dx dy. Why I have taken dx dy? Because mass is distributed in a plane. Then your variable is actually dx into dy. So you can easily find I y dash. And now this is double integral or single integral?
Double integral.
Double integral. So you will go for x, and hence this is my origin. So x will go from where to where? Minus a by 2 to plus a by 2. And b will be minus b by 2 to plus b by 2. And you have x square dx dy, and you have m upon ab. And if you are going to calculate I y dash, that value is m upon ab integration minus b by 2 plus b by 2 dy is here. You have minus a by 2 plus a by 2 x square dx. And now, surprisingly, what you will get? क्या मिल रहा है? ma square by 12, isn't it? देखो, ये वाला b हो जाएगा, b से b cancel हो जाएगा, and you will get ma square by 12, and you have exactly same value what you have find for the rod. Rod जब center of mass से जा रहा था तो, yes. Now similarly, what will be Ixx dash? बताइए.
MB square by 12.
mb square by 12. और वहां पर परपेंडिकुलर डिस्टेंस क्या हो जाएगा? दैट विल बी y, है ना? समथिंग लाइक दिस. इसके अबाउट ले रहे हैं, देन दिस विल बी माय परपेंडिकुलर डिस्टेंस, एंड यू विल गेट mb square by 12. Now you have moment of inertia about this axis. You have moment of inertia about this axis. Then you can easily find the moment of inertia about I zz dash by Ix plus Iy. And that value is equal to m by 12 a square plus d square. Clear है ये? सही है ना? Now आपने किस एक्सिस के अबाउट निकाले? You have just find moment of inertia about this axis. Now you have to find the moment of inertia about this axis. Is that these two are the parallel axis? Yes. और क्या ये एक्सिस भी सेंटर ऑफ मास से ही जा रहा है या नहीं?
Yes, sir.
Yes.
Yes.
So you can easily find, you can usually use parallel axis theorem. So when you are going to use this parallel axis theorem, now let's try to go for this. So I about A is equal to I center of mass plus m d square. And what is I center of mass? Now you can see this is also passing through center of mass. This is also passing through center of mass. This is also passing through center of mass. And which axis is useful for you depends on what you want to calculate. This is very important. So what is ICM for? If I want to calculate the moment of inertia about this axis, then I have to find ICM about this particular axis. So what will be ICM here? M by 12 A square plus B square. Now M, what is your D? What is your D?
So under root a square plus b square by 2.
Very good. So this distance, na? By 2 या
Yes,
by
sir.
4?
By 4.
मतलब
By 4.
सर हटा दिया वो.
This and this, na? So D is nothing. So you can easily calculate D. D is equal to what? This distance square plus this distance square. So what is this? अच्छा आप ऐसे कर रहे हो. A square plus B square by 2. Okay, good. So you have to just go for D square. Then you will go for A square plus B square by 4. And then you will have exactly M by 3 A square plus B square. Are people comfortable? So you can easily use this particular perpendicular axis and parallel axis theorem to calculate different types of problem. Okay? So now you can see this is the very fundamental theory जिसका कि आप use कर सकते हो. So we will use in the next class we will use different type of system basically, and you will also see that this when you will going to calculate you can just compare the thing from the moment of inertia tensor. आप जब इसे कैलकुलेट करोगे तो मोमेंट ऑफ इनर्शिया टेंसर के डिफरेंट कंपोनेंट से भी आप कैलकुलेट करोगे एंड यू विल फाइंड यू आर एक्चुअली कैलकुलेटिंग द डायगोनल टर्म. You are just going to calculate what? Nothing but what? Diagonal term. Depends on what is your axis. Okay. So this is just a glimpse how to use this particular concept of parallel axis theorem and perpendicular axis theorem. Tomorrow we will solve different types of problems. ठीक है? So tomorrow we will finish this particular topic. आज के लिए इतना ही. ठीक है?
Okay, sir.
Thank you.
Thank you, sir.
Thank you.
you.